so today we're going to be doing our families of functions lessons. It is 3.4. And I'm going to start with my own function called the greatest integer function. So this is a little confusing. It's the greatest integer less than or equal to x. So remember, integers are positive or negative whole numbers. And so you're looking for values that are greater than or less than or equal to x. So for example, if you choose the number 4x, let's say you choose 1/2. That's a little light. Let me write a little darker. 1/2. What is the integer that is less than or equal to x? So the closest integer to that without going over. Without going over the value. 0, yeah. If we do like 1.7, what is the integer great or less than but not over that? Claire? 1. Yeah, that is the greatest integer equal to but not over that number. Likewise, 2.8 would be 2. That's the greatest integer less than or equal to 2.8. It's kind of like Price is Right, where you want to get as close as you can, the integer as close as you can without going over that number. So 3 would be going over. So what that ends up looking like is interesting. So let's look at our graph. Anywhere between 0 but not quite 1, it's going to be 0. And once you hit 1, the greatest integer function outputs 1. So at 1, 1.1, 1.2, 1.3, those are all there. But as soon as I get to 2, the number that is closest to that number without going over, that is an integer, is going to be 2. So it jumps up to 2. And then you have, again, another step. And then at 3, it jumps up to 3. So again, it is the integer that is as close to the given number without going over it. Okay? That's what the greatest integer function does. Now let's consider some negative functions. How about negative 1/2? So the integer that is as close to this integer without going over it is what the greatest integer function, Andrew? -1. Yeah, I think negatives are a little trickier because for positive numbers, it just truncates. So if it's 1.7, you go to 1. 2 point whatever, you go to 2. But for negatives, you have to actually go lower. You're not just cutting off. And that's what you're doing with the regular numbers, but going lower looks different for negative. So I can continue my trend down here of this weird looking graph. How about negative 4.7? What is the integer that is closest to that without going over? Okay, so if you consider all the numbers, the integer as close to 0 without going over is 0. That's going to be true for all 0 points. So 0.1, 0.2, 0.3. The integer that it outputs is 0. Now, if you put in 1 to the function, what integer is as close to 1 without going over? It's 1. So that's why it jumps. So you can see the range of this function is integers. That's why it's called the greatest integer function, or INT. So that's why you have these jumps, because the output, f of x, is always going to be an integer, not anything in between that. The input can be any real numbers, and so that's why you have this, what is called a step function. Some people call it a step function.
So until it gets there, it doesn't go to the...
Right, so 1, 1.2, 1.4, 1.6, it's all 1, because that's the integer that's as close to those numbers without going over. But once you enter in 2, it's just 2. Other questions? So the domain is all real numbers. The range are integers, hence the name greatest integer function. And again, it's your first function that actually is denoted by like a phrase. The name of the function is intx, meaning it is the greatest integer less than or equal to x. I like thinking of it like the Bob Barker, Price is Right, where you're getting as close as possible, the integer that is close as possible without going over. Negative 4.7 would be negative 5. Okay, so our domain is any real number. Our range are integer values, and I think we can get that range from doing our scan. It's beep, 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 beep. It's not continuous. It's just hopping like stairs are. So that is the greatest integer function. You can see there are no extreme value because there's no changes in direction. There's no symmetry. It's kind of weird. Actually, does it have origin symmetry?
No.
So remember, if we flip and then double flip, I think we have the issue with the holes being on the wrong side. The holes in the function end up being on the left instead of on the right. So no symmetries. Sarah?
So when you got into the negative, shouldn't it be the other way, so it's less than?
Yeah, so you have to think of the number that it is close, the integer that is as close to negative 4.7 without going over negative 4.7. If you put in negative 4, would you be over? You'd be over.
Yeah.
So this is the integer that is closest to it without going over it.
So wouldn't the graph be a circle there?
So if you're negative 4.7, that's really the same thing as negative 1.7. Negative 1.7 goes to negative 2. So, yeah, I forgot to fill this in right here. The closed are always on the left.
Oh, but once you get to negative one, that's negative one.
Yeah, so anywhere between negative 1 and 0, it's negative 1. Yeah, kind of a weird one, right? So that's why I chose to teach that one. We're not going to get into the extensions today, but we will later. All right, any other questions? All right, so let's start with our first group, which I think is our quadratics group. And did you all share something with me?
Yeah.
Okay, I will bring it up. You all can go on up. So let's see. All right, whenever you're ready.
All right, so our function is fx equals x squared. For the domain and range, the domain will be all real numbers or negative infinity to infinity, and the range would be 0 to infinity. Does anyone know why the range wouldn't be negative infinity to infinity?
It's a square number, can't be negative.
Okay, the intercepts. Intercept would be 0, 0 because it touches only at the origin, and from there, it never touches the x-axis again or the y-axis.
For these symmetries, their x-axis, which would you plug in f of negative x. So if you put in negative x squared is equal to x squared. Wait a second. Did we do this right? So I think we switched around x and y axis symmetry. So if you plug in x-axis, if the y-axis symmetry, you plug in x for negative x. So then negative x squared is the same thing as x squared, so it has y-axis symmetry. So you can see, like, if you flip it over along the y-axis, they line up. And then x-axis symmetry is then negative f of x. So if you plug in x squared, that would be f of x, but if you take the negative of x squared, that's not the same thing as x squared, so it doesn't have x-axis symmetry. And then origin symmetry is the same thing. Negative x, if you plug that into the equation, is also equal to x squared. And then x squared is not equal to the negative of x squared. So, and then increasing, decreasing are constants. You can just use like the arm test. So if you're going along like this, it's decreasing from negative infinity all the way to 0. And then there's a absolute minimum right there, and then it starts increasing after 0 all the way up to positive infinity. So there's no constant.
So basically, this is the addition part of the extension. Before we had the parent function, and after we add 5, the y-intercept goes up 5 because there is a vertical shift upward, so that therefore the new y-intercept is 5. Okay, so there is no local maximum or local minimum. The absolute minimum is 0, 0, the origin, because that's the origin, because that's the only place where the function or the graph touches the x and y. Yes, and then the absolute maximum is infinity because it keeps on increasing, and there is always a square of the number. Okay, so do the subtracting extension. So if you would subtract 6, what happens is your y-intercept would go down to -6 because it's slope-intercept form, and so it starts from -6 and it goes up. So now it will cross through there's 2 points of x-intercepts, and then it changes the y-intercept, or it changes like the intercept. So there's 3 intercepts, 2 on the x, 1 on the y, and it stretches up the graph. It makes the graph get smaller.
For the multiplication extension, so I multiply the function by 7, so you get function of x is 7x squared. So if this is a function before, and you can tell it kind of squishes in after, so the function's curve looks a lot steeper, so you can probably guess what the domain and the range are for this one. Yeah, what's domain and range?
You get a Twix if you have.
Real numbers and 0.
Yes, that is true. And then the intercepts, they stay the same as well. The intercept is 0, 0. That is the only intercept there is 0, 0. The symmetry, the symmetry is the exact same as before. It's just more squished in, but -7x squared is the same, or x squared is the same as -x squared. So then for the areas of graph increasing and decreasing, it is also decreasing from negative infinity all the way to 0, and from 0 all the way up to infinity. And then the extrema, the absolute maximum is just infinity because it's infinitely going up, and then the absolute minimum is 0 because it's never past 0.
Yep, you have a point.
You're out of time.
What? Hey, you had one.
So division, what happens when you divide by 3? There is a vertical compression. Oh my god. There's a vertical compression of by the factor of 3, which means that there's a more gentle, there's a gentle slope, you know, and basically because you make a number smaller, so it's more, basically because you divide by 3, the values of the equation are widened out. So, is there any questions? Are there any?
Wait, so the absolute minimum and maximum can be infinity?
The absolute, can we go back to this? Okay, so the absolute maximum is infinity because there is an infinite amount of numbers and square root, yeah, infinity is time. And then the absolute minimum would, yeah, it's 0 because that's the only place where the graph or the function.
All right, we gotta move on. Let's give him a round of applause. All right, thank you, gentlemen. Next we have Shrieker and Claire. Okay, and I will raise my hand in the air when you're out of time. And I'll try and give you a 1-minute warning. Okay, thank you.
Okay, so our function was x was 1 over. So you can see that on the graph. You can see how it gets infinitely closer to x-axis without ever touching it. That's why the range is all the way except 0. And it's the same thing for the domain, because it gets infinitely closer to the y-axis without ever touching it. And so that ties perfectly with the intercepts. There are no intercepts because in order to have an intercept, the x value or the y value has to equal 0. But in this case, it never touches the x or y axis, so you can't have any intercept. And also another reason why you can't have y-intercept is you can't have 0 in the denominator of the function. That's one of the rules.
Okay, so the symmetry is odd, which is origin symmetry. You can tell this by looking at it, but if you think about it mathematically, when you put f of negative x, you get 1 over negative x, which is the opposite of 1 over x and the opposite of the function. And you can also clearly see the origin symmetry on the graph when you flip it to the right and up, it's 1.
Wait, what was the? That's a good one. Sorry.
Does anyone have any questions so far?
But eventually the question.
Yeah, because it's not even. Okay, where it increases, decreases, and stays constant. So it's always decreasing. It never increases or stays constant. You can see it from the top of the function. As numbers of x get larger, the function keeps getting infinitely closer to 0, and therefore is decreasing the whole time. It's not staying constant. But if you think about this logically, when you have a larger number, when you put, for example, f of 2, you get 1/2. And since this is a fraction, as the numbers get larger, when you have like f of x is 1 over 20, then that's 1/20th, and that is much closer to the x-axis because it's getting closer to 0 as the numbers increase.
Sorry, I was writing. Oh, nice.
So for the extremas, there are none because in order to have an extrema, it should look something like this. So it can either increase and then decrease, or it can decrease and then increase, but there has to be this kind of point where it stops increasing and decreasing. And on this graph, you can see that it's always decreasing, so it can't ever have an extrema.
Okay, so for our what if problem, we did is f of x is 1 over x squared. So now the function is not odd, it's even in its y-axis symmetry because when you square a number, it cannot equal a negative number.
So the domain is still x cannot equal 0 because, again, you can see it's getting infinitely closer to the y-axis without touching it. And this is for the same reason. You can't have x in the denominator because then it no longer is a function. But for the range, it's now y to be greater than 0 because, as you can see, the function never actually hits the negative portion of the graph. And it's also getting infinitely closer to the x-axis without even touching it. So that's why it has to be greater than 0. And there's still no intercepts because the function never touches either the y-axis or the x-axis. And again, for an intercept to occur, either the y value or the x value has to equal 0. And there's still no max and min because it continues decreasing forever. And in order to have a max and min, it has to increase at some point.
Yeah. And when you look at this graph and think about it, like if you have f of 1, you have 1 over 1 squared, which is 1, 1 over 2 squared, which is 1/4, and that's why the numbers keep getting closer to 0. And same thing with the negative numbers. When you square them, they're positive, and it's the same on the other side because when you square the numbers, they're the same.
So, any questions? Okay. Like your
Thank you.
Okay, Justin and Sam. Let's see. Not that. I think this might be as good as it gets. Oh, hang on. Let me try. Oh, it's getting smaller. Weird. Okay. There we go. Okay.
We have absolute value function, and as you see on the graph, it never goes below. It's never negative because absolute value is always positive. The domain will be all real numbers, so negative infinity to positive infinity, and the range will be practically 0 to positive infinity because the number goes negative. The only intercept will be 0 because that's the only time the function is accuracy. It's an even function, so there will be y-axis symmetry, and it's increasing from negative infinity to 0, and then it's decreasing from negative infinity to 0, and increasing from 0 to positive infinity, and the only extra one will be an absolute minimum at 0.
So what would happen if you made the absolute value negative? Well, it would just flip over the x-axis. And so now the domain and range is the domain is any real number, and the range is any real number greater than or less, equal to or less than 0. The intercept would still be 0, 0, because now that it's negative, it can't go over. And it still has y-axis symmetry, and it's still an even function. But now it's increasing from negative infinity to 0 and decreasing from 0 to infinity, it has an absolute maximum at 0, 0. Would it decrease from, what would it be? So it would decrease from negative infinity to 0. Okay, yeah.
The slope is lessened and it's more widened, but it's also still y-axis symmetric and the domain and range is the same. Yeah, nothing really changes except the slope is steeper.
And so then the opposite happens when you multiply. The slope increases because it's a lot like the y equals mx plus b equation. You're multiplying x times 5. So it just increases the slope. Everything else remains the same.
This is what happens when you add inside of the humanoid. The function moves along the x-axis. You can think of this as 0 equals x plus 3. And if you subtract 3 on both sides, negative 3 equals x. So that's why that moves. And when you add outside of the humanoid, that's only the y-axis. I mean, the y-intercept changes, and it will be 0, 3.
Yeah, pop quiz. I was gonna bring like a bag of dum-dums and then give them out when you answered the question.
I actually have dum-dums.
You do? You
I-
use them?
You can.
That's perfect.
I mean, you can not only use them, but keep them. Because I definitely don't want them back.
That's nice. Alright, I don't want to throw them at people. So I'm
Do
gonna-
it up.
So does anyone want to go ahead and try to answer those? Nobody does? Alright, is the domain all real numbers? Yes, sir. What?
The range is like, whatever that is, slightly less than 1 to infinity.
Oh.
They're throwing suckers.
Intercept is roughly 1, 0.9 Ava?
Y-axis symmetry.
Yep.
Ryan?
It is decreasing from negative infinity to 0.
Patricia?
It increases from 0 to infinity.
Tara?
The only is positive and
Yep. And if you can figure it out, my bad. If you can figure out the function, I'll give you just the rest of these. Any guesses?
absolute value x plus 0.1.
Trigger?
Absolute value of x plus 0.75. Like the 0.75 is not an absolute value.
Ryan?
Absolute value of x plus 0.75 divided by like 3.
Okay, you're onto it. It's not, it's plus a whole number. And then it's divided because the slope is, yeah, just y equals x plus 0.75. No.
So y equals, or f of x should equal absolute value of x plus 12 times 1.
No. Ryan?
Absolute value of x plus outside plus 3 divided by 4.
Yeah!
Yep. Sorry, I just got it right. I was trying to figure it out.
Oh yeah. Dude, I am just throwing these. Yeah, that's it.
Yeah, Ryan, just take one more.
Yeah, Ryan. Oh,
All right.
yeah. Oh, sorry.
All right. Ava and Tara. Who am I looking for? Here's Tara.
Are you gonna throw them? Okay, so we have the function that. Okay, so that's what the function looks like. Can anyone say the domain and range of the graph? Stop answering. What is the domain?
All real numbers.
Yeah, What are the
Oh.
intercepts? What are they? Patricia.
Ooh.
What was the y-axis?
Oh, okay, yeah. What areas of the graph are increasing?
It's increasing from negative infinity to 0.
Yeah. Decreasing, yeah.
Infinity to 0.
Well, 0 to, yeah.
Oh.
Okay, we need to pause for 1 second, you guys. Picture a little bug on the left side of that graph at the bottom. Picture a little bug down here. Do you see where my cursor is? It's always increasing. So when you're doing increasing and decreasing, you always go left to right. So you're following the journey, not from the origin, but left to right. That can be confusing. Okay.
What are the extreme ones? Where? None. Yes. Okay, so does anyone have?
Cora, I have to do something.
Oh, sorry. Sorry. Yeah.
Okay, so, does anyone know what minus x cubed might look like? Sam?
You just look at
Yes. Okay.
That's so the that works.
Okay, so can anyone guess what that might look like? Just like, try your best to explain it.
You like,
Yeah, you.
That is Armand. He's new.
We have 4 classes together. I forgot your name. Sorry.
We have a new student.
I don't know how to say it in English or in anything. I'll just, could you
Okay, yeah.
turn it?
Is that what you were thinking?
Yeah.
Okay. And what do you think this would look like? That's over there. Yeah. Emma.
I think that's the graph between.
Yeah,
Down the white. There.
How come I didn't pick? I don't want. I thought you did.
Or you can cube it, Emma. Are you guys done?
Yeah.
Did you ask if there were questions or no?
Go back to the first.
Do you want to see the first slide, Armand? I wasn't gonna say anything. All right, so Emma and Karishma.
I was literally the same fucking class. Dude, you just can't put any color on January. You should have original. Oh, no.
goes across. If it goes across, from left to right, where you can find the domain, so, or you can write it as it goes from 0 to infinity.
If you were to scan it out for the range, you can see that it would be all real numbers that x has to be greater than or equal to 0, or hard bracket 0, infinity, soft bracket.
For the intercepts, it's just the one intercept that's 0, 0 for the x and y intercept.
There are no symmetries because if you were to do the folding graph test, no matter how many it would not. There wouldn't be anything that would fold over itself and equal each other.
So it's increasing from 0 to infinity, and then there's no decreasing or no constant, because it's just continuing to increase.
For the extreme one, the absolute minimum is 0, 0, or x equals 0, and there's no absolute maximum. You can just continue on to infinity.
Okay, so for the first modification, it's addition. So basically, the value of x is just we add 4 to it, so the values go up by 4 in the y-axis. So it changes the y-axis.
Before we go on, does anybody have any questions? If you're with that.
Any questions?
So if you modify the equation and subtract 4 from the equation, and you change the y-axis to -4, and then there would also be an x-axis present, since the y-axis is moved down.
So for multiplication, the value of the squared x is now multiplied by 4, so it has a larger more gradual curve because it's multiplied by 4. Each point is multiplied by 4, so it's much larger.
If you were to modify the equation and divide the function by 4, there would be a smaller slider curve on the graph. And because the function is divided by 4, and if you think about it kind of logically, it would be like 1/4 of the function, so it would have to be smaller.
Okay, so it's going to be a question.
If you don't like Snickers, you'll probably just take something else.
Yeah. Okay, what is the domain of the original function?
Any real number greater than or equal to 0.
Do you want Snickers?
Yes. Thank you.
Do any of the function graphs have symmetry? True or false, the domain and range are the same of the original function.
Sorry, I really like Snickers. False. False. No, I just got it. Thank you.
Is the curve larger on the division of So for the 4 modified graphs, the y values are independent. Yeah. So for the x and y is by the sum. And then repeat that. And you are here.
Worth it.
What's the white one? Oh, okay.
The original function is called constant data. Like when increasing discrete and constant.
No.
Stickers?
Okay.
And the last question, where the two is, the perfect and perfect.
where the sewage is. Like with the parentheses thingies and like with the all real numbers, the X equal that. Or Y. Or something like that. You could do like this number and then go to Y. Or just bracket.
I think if we're X is greater than or equal to 0 and then hard bracket is 0.
But it's range Y.
Yeah. So it would be Y.
So Y.
Oh yes, Y, sorry, yeah.
Christopher on a dime.
All right, Patty and Jeff.
For this one, the original.
I thought you were like, or Y is greater than. No. I'll trade you a Jolly Rancher.
Oh, yeah.
I like Jolly Rancher.
It's getting crazy. Square root function? No, you can't plug negative numbers into it.
Insane.
So,
So the domain are all positive.
yeah, so
Oh,
X is greater
yes.
than- So then they'd be the same, X is greater, or X or Y is greater.
So,
Yes, for the original.
well, if you want graph of Y equals times X, and what you can line, so there's no getting direction. So, what is the domain?
Any room with it.
Oh, I gotta reach the whole, wow.
And so your function is to be negative infinity. You can also figure this out by looking at the equation because there's no fraction, so you won't have to worry about dividing by 0. And since it's a cube root not a square root, you don't have to worry about the negative or radical, so it'd be all real numbers. And what do you think the range is? And the function doesn't make sense. So we have a table, so if x equals 8, y equals 2. So what would x equal if y equals -5? Fine.
Negative 125.
Wow.
And if x equals 343, what would y equal? You take the cube root of 343. This is no
Can't believe I'm
Is it 7?
Oh, no.
It's my day today. Oh, this is legit here. All right.
What kind of signature do you think it has? Ava. What is it? Origin? Oh, yeah. That's origin signature usually. And you can figure this out by looking at the graph and you think that it was the line, or you can take the equation y equals the cube root of x, and you can make the y value of x value negative and choose, and you get negative y equals the cube root of negative x, and then you could flip the equation, flip the side of the equation, and you get 2x equals y, which is equivalent to y equals the cube root of x, so we have origin signature. Are there any absolute minimum or absolute maximum values? No. Are you? Yeah.
For expansion, what would the graph be if it's f(x) equals square root of x plus 1?
No.
I was gonna. For the second one.
Ooh.
Okay, I only have 3 more. Oh, does this graph have any?
Yes.
Use your eyes. Figure.
No.
What about after x over 2?
Wait, what? What does that?
Like over 2. What is that? 2 of x over 2.
Would the graphs be smaller?
Yeah. This one will be small.
Right. Thank you.
All right. Nice job, you guys. Overall, pretty much excellent performances. Little hiccups, but nothing major. Over the weekend, what you're going to do is analyze your knowledge of these functions on the homework. So the assignment does include evens and odds, but you can, here's the greatest integer function, just circle back to that. But you can always use your graphing calculator to help you answer the evens if you aren't sure of that answer, because all of these are graphable on the graphing calculator. You want to do it real quick? Okay. So Justin and Sam, most of the graphing calculator things are very straightforward. The one that's really not is the absolute value function. So Sam and Justin, we're going to just walk through how you use the graphing calculator to graph absolute value functions. Yeah, so that'll pop up on the screen.
The ABS parentheses, the absolute value thing, press enter, and then you get the
Yeah. All right, do you guys need him to write that down, or did you find it? Okay, thank you, Justin. All right, so again, here is the assignment. And again, be sure, if you're not sure about your even answers, you can use your graphing calculators. With that, I did want to mention your graphing calculators will not be allowed on the next test. So if you're using them as a crutch, you might want to get rid of your crutches.